Hello! This will be a demonstration of Proposition 34 from Book 7 of Euclid's Elements, which tells us, given two numbers, to find the least number which is measured by both of them. This is the problem of finding the least common multiple of two numbers. We're given two numbers, of course. We're going to call them A and B, and our task is to find the least number which is measured by both of them, or in other words, the least common multiple of A and B. Now, if A and B are prime to each other, then what we're going to do, we're just going to take their product, so we're going to multiply A and B by each other, we're going to make C. So that A and B both measure C just by the definition of multiplication, that A measures C according to the units in B, and B measures C according to the units in A. So C is measured by both A and B. So it's a common multiple. Now, if the number C is not the least common multiple, then some other number will be the least common multiple. We'll call that the number D. So the number D is less than the number C, and the numbers A and B both measure the number D. Now, what we're going to do next is we're going to create two other numbers, E and F. Now, E will be created such that there are as many units in E as there are A's in D. And we're going to create the number F likewise, such that there are as many units in F as there are B's in D. So that A times E makes D, and B times F also makes D, again, simply by the definition of multiplication. There are as many A's in D as there are units in E, so we can say that A times E makes D, and likewise, there are as many B's in D as there are units in F, so again, just by the definition of multiplication, 7/15, we can say that B times F makes D. And because both of these products, A times E and B times F, both make the number D, by common notion 1, they're simply equal to each other. So A times E is equal to B times F. And then, because A times E is equal to B times F, we can turn this statement about products into a statement about proportions by Proposition 7/19 and say that A is to B just as F is to E. Now, remember, we started out at the first step by assuming that A and B are prime to each other. And because they're prime to each other, they are the least numbers which have their ratio. So A and B are the least numbers which have the same ratio as F and E. We know that by Proposition 7/21, and then by Proposition 7/20, we know that the least numbers which have the same ratio with two numbers measure them the same number of times. What that's going to mean for us here is that A is going to measure F the same number of times that B measures E. That whole statement isn't all important to us. What we just need to know is that our number B does measure the number E. Now we notice that our number A has been multiplied by two numbers B and E to make two different numbers C and D. So A times B has made C in our first step, and A times E has made D. We established that in our third step. So we can say by Proposition 7/17 that the products have the same ratio as the numbers multiplied. So B is to E just as C is to D. And because B measures E, that is, that B is a part of E, we can then say that C as well is a part of D. C measures D. Again, that's just by the definition of proportionality. And because C measures D, C has to be less than D, just naturally. But remember, we made D to be less than C. So our number C is both greater than our number D, and it is less than our number D, which is just impossible. And so we can conclude that there is no number less than C, which is measured by both A and B. And what that means is that we have found our least common multiple of A and B, and this is the number C. Now, this isn't the end of the proposition, because we still have to deal with the case where A and B are in fact not prime to each other. But I'm going to cut the video here and move on to that part of the prop, because I don't have enough board space, so I'll see you on the other side. Okay, so next we're going to deal with the case where the two given numbers A and B are not prime to each other. If they aren't prime to each other, what we're going to do is we're going to take their ratio and put it into simplest terms, right? We did that in the previous Proposition 7/33, what that's going to look like is we're going to have the two numbers f and e be the least numbers which have the same ratio as a and b. Now, because f is to e just as a is to b, right, they have the same ratio, we can turn this statement about proportionality into a statement about products, remember by proposition 719, so that because f is to e just as a is to b, we can say that a times e is equal to b times f. Next, we're going to multiply a times e. We're just going to call that product c. And so because a times e makes c, and a times e is equal to b times f, combination 1 tells us that b times f is also equal to c, so that our two numbers a and b both measure c, right? So a measures c according to the units in e, and b measures c according to the units in f. So c is a common multiple of a and b, as it were. Now, if c is not the least common multiple, there's going to be some other number, which is less than c, that is a common multiple of a and b, that is measured by both a and b. And we're going to call this the number d. So our number d will be less than c, and our two given numbers a and b will measure d. Next, we're going to create two more numbers, g and h, such that there are as many units in g as there are a's in d, and there are as many units in h as there are b's in d. Now, because this is so, that there are as many units in g as there are a's in d, we can say, just by the definition of multiplication, that a times g makes d. And likewise, you can say that b times h also makes d. And so these two products are both equal to the same number, namely the number d, so combination 1 tells us these two products are equal to each other. So a times g is equal to b times h, and again by proposition 719 we can turn this statement about products into a statement about proportions, so that because a times g is equal to b times h, we can say that a is to b just as h is to g. But remember, in step 8 up here, we had made the numbers f and e in the same ratio as a and b, right? So a is to b just as f is to e, and we've just shown in the previous step that that a is to b just as h is to g. So we have two ratios which are the same with the same ratio, property of numbers, they're in the same ratio with one another. So f is to e also just as h is to g. Now remember that f and e are the least of those which have that ratio, so that we can say by proposition 720 that those least numbers will measure any numbers in the same ratio the same number of times. So f is going to measure h the same number of times that e is going to measure g. Not all of that statement is important to us right now. We just care about the fact that e does in fact measure g. Now if you remember, we've taken the number a and we've multiplied it by two numbers e and g to make two other numbers c and d. Remember, so a times e, remember in step 8, has made the number c, and a times g makes the number d. We did that in step 10 or 11. So that because a has been multiplied by two numbers, making two products, the ratio of those products is the same as the ratio of the multiplied numbers, so that e is to g just as c is to d. We know that by proposition 717. So e is to g just as c is to d. Now in step 12, we proved that e measures g. And what that tells us here is that because e is to g, e and g have the same ratio as c and d have, and e measures g, we can then say that c also measures d. And since c measures d, c is therefore less than d. Well, you remember in step 9 that we made the number d to be less than the number c. So the number c is greater than the number d. Well, we just proved in step 14 that the number c is less than the number d. So the number c has to be both greater and less than the number d at the same time, which is just impossible, of course. So we can conclude that there is no number less than c which is measured by both a and b, which tells us that the number c, which we've made, is the least common multiple of a and b. And this is what we wanted to find. We wanted to find the least common multiple of a and b, and we've just done that. So we're done with the proposition q, e, f. Just to give an example of what this would look like going through two particular cases. Remember, so the two cases are a and b are prime to each other, and they're not prime to each other. So first case, they're prime to each other. 4 is prime to 9. So the least common multiple or the least number, which is measured by the both of them, is just going to be the product of our two numbers, in this case 36. There's no number less than 36, which is measured by both 4 and 9. But what if they're not prime to each other? Let's say it's 6 and 8. So we want to find the least common multiple of 6 and 8. What we're going to do is, because they're not prime to each other, they're not the least numbers which have the same ratio with them. So we're going to reduce them to least terms. And what that's going to give us here is just 3 and 4. Okay? And what we're going to do from here is we're going to multiply so we're going to just take the product of 6 and 4, or we're going to take the product of 8 and 3. They'll be the same thing, and that'll be the number 24. And so what that tells us is that the least common multiple of 6 and 8 is the number 24. You can verify that these are true, so you see that this method that Euclid has laid out in proposition 734 does hold. That's all I've got to say about this one, so I'll end the video here and move on to proposition 735.